Okay, today we're going to go over how to solve linear equations with variables on both sides of the equation. So we have two problems up here on the board. And as you can see, unlike yesterday, we have an x on the left and an x on the right. We're still going to solve them the same exact way we did with variables on one side of the equation. But instead of moving just the numbers around, we're going to move the variable from side to side and get it all on one side of the equation. So we can start this out by solving it in many different ways. You can either start with a variable or start with a constant. So let's start with a variable. So I have a 3x on this side and a 2x over here. If I want to move the 2x from one side to the other, I always do the opposite of whatever it's telling me to do. This is a positive 2x, but I want to take it away on this side. Well, if I take it away from the right side, it means I got to take it away from the left side. That cancels out the 2x on the right. Now, if I write this out, I still have 4 out in front. 3 minus 2 is just a simple x. And then that's going to equal my positive 1 over here. So I've taken the variable on both sides. I moved it over just to the one side. Now we're back to solving for a variable on one side of the equation. If I want to get x all by itself, I need to take away the 4. Subtract 4 from that side. Subtract 4 from the other side. These cancel each other out. I drop down my x. That's going to equal 1 minus 4, which will give me a negative 3. And there you go. You solve for x. You got one solution. All right, over here, I still have variables on both sides. It doesn't matter which way you move them. But I always like to try to have a positive variable whenever I possibly can. So I'm going to subtract 3x from both sides here. Take away the 3x over here. That way I won't have a variable on the right side of the equation. And I got to take a 3x away over here. All right, notice we're taking 3x away from both terms with the variable. I can't take a 3x away from a negative 4 or a positive 2 because they're not like terms. Those two would then cancel each other out because 3 minus 3 is 0. 6 minus 3 is 3x minus 4 equals 2. Now I'm down to a multi-step or two-step equation. Okay, so I want to get rid of the negative 4 because that's not really attached too much to the x. So the opposite of subtracting 4 would be to add 4 on both sides. That cancels that part out. All I'm left with on the left side is 3x. That's going to equal 2 plus 4 is 6. Then the opposite of multiplying by 3 is to divide by 3. So I'm going to divide both sides by 3. So x is going to be 2. There we go. So we've had two equations here. We've had variables on both sides. We simply just move the variable over to the other side and solve for x because we're looking for one solution. All right, let's get to the next screen. Let's try something a little bit more complicated. It has a couple more steps in it. All right, so the left side. Let's try to clean up the left side and then try to clean up the right side a little bit. So what can we do to the left side? Because I have two variables over here and only one over here. Well, if I have two variables on one side, I can combine them together. So 3x plus 4x would give me 7x, but I still have the minus 10. So I just combine my x's together, I got 7x, and I still have my negative 10 or my minus 10. Now over here, I got parentheses, so I want to use the distributive property. So I want to multiply everything on the inside of the parentheses by negative 2. So that would give me negative 2 times x gives me a negative 2x. And then negative 2 times a negative 4 gives me a positive 8. And I still have that 9 out there. I haven't done anything with the 9 yet. All right, so we use the distributive property. We got negative 2x plus 8. We drop down our 9. Now, just like over here, like we combined the terms with the x and the variables attached to them, we can now combine these two constants together. So let's rewrite this as 7x minus 10 because we're not doing anything at all with the left side on this step. I still got my negative 2x, and then 8 plus 9 is 17. So now we're right back to where we were in the last screen. We had one term on each side that had a variable and one term that was nothing more than constant. All right, so here I can move my x or my variable over. The opposite of subtracting 2x is to add 2x. I can do that to both sides. That would cancel it out. Now 7 plus 2 is 9x. I haven't done anything with the minus 10. You still got to leave the minus 10. And that is going to equal 17. So now we've gone, once again, we've gone from having a variable on both sides to just having it on one side now. Now we can just solve for x. All right, now let's move the 10 over. If it says minus 10, it means we've got to add 10 to both sides. If I drop down my 9x, that will give me 9x equals 17 plus 10 is 27. Then like we usually do, the very last step is a division problem. So if I divide both sides by 9, oops. That's for the last one, here we go. X is going to be 3. So there we go. And don't forget, you can check your problem, especially if you're doing a test, by taking and plugging the 3 back into both sides, and both sides should balance out. Now, there are a couple of exceptions where you will not just get one solution. And this will definitely come up in your algebra class. So these are special cases where we just don't have one solution. Now let's see how they work. All right, so we have the purple one here. Well, I can't really do anything with the left side. I can't really clean that up at all. But I can distribute on the right side, all right? Whenever you get stuck doing an algebra problem, try to find one thing to do on the first step. A lot of times if you do something on the first step, it's going to trigger a memory on what you can do for the second step. So 4x plus 6, that's going to remain the same. Here I saw the parentheses, and I knew I have a number outside the parentheses. I can multiply that number times every item on the inside of the parentheses. So 2 times 2x gives me 4x. 2 times 3 is a plus 6. What does this show you? What do you notice here? Both sides are equal to each other. They're exactly the same. Whenever you come up with something is the same on both sides, it's going to end up being an infinite number of solutions. Basically, any number you plug in to one side, you plug it into both sides, it's going to level it out. Like, for example, if I want to take away the 4x here, it's going to cause me to take away the 4x from both sides. All right? So then that would just give me a 6 on this side and a 6 on that side. So whenever both sides match perfectly, we say that that is infinite. Some classes, some textbooks will say infinite solutions, or you could say many solutions. All right, so whenever it cancels everything out, you have a number on both sides, you've basically gotten rid of the variable totally. And it's exactly the same. It's infinitely many solutions. Meaning I could plug a 1 into both sides and it would work. I could plug a 2 into both sides and work. Any number I plug into both sides, it's going to keep the equation balanced. All right, let's do this one over here. So I can't do anything with the 6x minus 5. But I can distribute on the other side. So 6x minus 5 will stay the same. And then over here, 2 times 3x will give me 6x. And then 2 times 4 gives me a plus 8. Now, we're back to trying to get both variables on the same side. But here's what's going to happen. If I subtract 6x from both sides, because say I want to move this 6x over, like I'm trying to get 1x remaining. But by doing so, basically I'm going to end up subtracting 6x from both sides. Because that'll happen sometimes. That's going to leave me with negative 5 equals 8. Now, does negative 5 equal 8? No. They're not the same number. So whenever you end up with two numbers like that and they're not the same number, we say that this equation has no solutions. All right? What that means is no matter what number you plug in for x, it will never set both sides of the equation in balance with each other. It won't work. Now remember, you can only pick one number for x, but no matter what number I plug in there, it's not going to have the equation balanced. So there are no solutions for that equation. All right, so this is infinitely many solutions. You can plug any number in for both sides, and it's going to balance your equation. Over here, when the numbers don't match, it's no solutions. All right, hopefully that helped you out. If you're in my class and you have any questions, please ask me tomorrow. If not, give me a little like down below. Maybe subscribe. I have a couple subscribers on there, and I will talk to you guys soon.